Okay, so welcome everybody. We have a nice cozy group today, which is really nice in our comfy chairs, which is perfect for Are You Sick of Feeling Tired? Because we might put you all to sleep today, and then I'm gonna know what I need to have done to keep you awake. But we're going to talk today about energy crises in the body. What goes wrong? How do we lose energy? What happens to our mitochondria, which are the sort of energy generating plants inside all of our cells. But again, we're going to do a brief review, much briefer than normal, of sort of the foundational principles that we look at when we talk about functional medicine and the new preventive medicine. The very first thing, of course, is the ability to measure as the foundation of all science. So this is my professor, Dr. Gant, who I'm studying with, and I'm about 6 months out of 18 months into my training program, so I'm getting smarter and smarter. That's what he tells me. I don't know. And he says if you don't test, you've guessed. So we've got a lot of testing now that we can do that's very sophisticated. And the basic theory, again, is we look at systems. We look at how do different systems interplay one with the other. So instead of just looking at one small part of the problem, we look at the big picture. And there are 8 systems that we'll look at, and I'll go into that next. But the basic idea that is each tack represents a system in our body. So this 10-tack theory of Dr. Mark Hyman says that, look, if you step on a bunch of tacks, you don't take out 1 or 2 and then give somebody Advil. You have to remove all the tacks, and then you can go ahead. Well, you may give them Advil while you're removing the tacks, or lidocaine or something else, but you know what I mean. We don't stop removing the tacks. We have to get to the source of the problem. And then the way that we test in functional medicine is through what we call functional markers. And functional markers basically, instead of a blood level, and we'll take, for example, vitamin B12, we can measure B12 in the blood, but it stays very even in the blood. So if you just ate a lot of green leafy vegetables or took some B12 tablets, your blood level will be normal. But inside the cells, where processes need to happen, enzymes need to work, if you don't have enough B12, we'll see certain things go out of whack, like homocysteine, for example. So homocysteine is right here. This is highly dependent on the right amount of B12. So we can measure functional markers. We don't measure blood levels because oftentimes they're wrong. They just will tell you, oh yeah, everything's great, but your cells aren't doing what they need to do. So this is kind of the sophisticated look that we do in functional medicine. So for instance, homocysteine's right here, and it goes up to something we call SAMe, which is a brain chemical that stabilizes the brain. And homocysteine can go this way, down this pathway, to make glutathione, which is the body's most important antioxidant. So you see, if your homocysteine level is high, it means you're probably low in SAMe, so you're prone or susceptible to depression or sort of mood alterations, and your glutathione's going to be low because it's not getting converted this way. That means you're at risk for infection and things like that. So simple markers, simple blood markers can tell us a lot about what's going on in the body. Pardon me? A normal homocysteine should be between 6 and 9. So you don't want it too low, you don't want it too high. If it's high, if it's 15, this is a fascinating fact, if a homocysteine level is 15, on average, in epidemiological studies, those people will live 7 years less than if it's 10. So it's a very important number because it increases your risk for heart disease, stroke, Alzheimer's, a whole bunch of bad stuff. So we want to keep that homocysteine level down. And now here's the 7 stresses. I said eight systems, but there's 7. The 7 hidden stresses, and this is an acronym that I made up. So the H stands for hormone imbalance. That's 1 tack on the foot. We make sure the hormones are balanced. Second is inflammation. We had that talk already, and we talked about how fish oil is Mother Nature's anti-inflammatory. Then digestive disorders. We spent a lot of time looking at how can problems in the gut cause mental disorders. inflammation in the gut can create inflammation in the brain, and there's a gut-brain connection. Then last time we looked at detoxification issues, which was fascinating. We looked at some patients that were very susceptible to mercury, environmental toxins, and even hormones that don't metabolize correctly. If you remember, we talked about a patient who metabolized estrogen in a way that she created 4-hydroxyestrogens, which are carcinogenic, cancer-forming. So she had a gene that accelerated the metabolism of estrogen into a cancer-causing chemical metabolite, and then she was missing the gene that neutralized that, the glutathione transferase gene. So remember, we talked about how critical detoxification issues are. And heavy metals are one of the big things that we do see in a lot of people. In fact, unbelievably, I now have 4 patients that I'm treating for mercury toxicity, heavy metal toxicity, and I have 2 more that I haven't told yet that I just got their tests back. Yes, it's either dental amalgams from silver fillings, where the mercury, it's a vapor that goes and we swallow it, it goes into the GI tract and gets absorbed, or fish. Yeah, exactly. So, and again, if you remember, one of the major principles from the detoxification is that most people are fine. I would say, 75, 85% of people have no problem. Their bodies can handle even these chemicals that weren't around, for years before. But mercury and heavy metals, it can get rid of them. But for the small percent that is missing the gene, or their genes don't work just right, they're the ones that it can create tremendous problems in. And it's why so many studies come out showing mixed results. If you remember, when mercury amalgams first came out, the American Dental Association said, oh, there's no problem whatsoever, they're fine, there's no health risk. And I still have dentists telling me that. The problem is, it's maybe true in population studies where you say, oh, well, the majority of people have no problem from it, so it's okay. Well, but if you're in the minority, it's 100% problem for you. So that's the issue. And today we're going to talk about energy crises, another attack that can get stuck under the foot. And then next month we'll talk about nutritional deficiencies. You all know a lot about this because these we do measure in almost every one of you, like the vitamin D. This is where homocysteine would come in. We measure iron deficiency. Some of the neurotransmitters we don't measure in all of you, but many of you, we have measured them. And we'll talk about that next time. And then, of course, mental, emotional, spiritual stress. I think the big underlying thread for all of this, and it goes back to my training in mind-body medicine, is thoughts and feelings are chemical. Mental stress it's attack. It's the biggest attack because it's pervasive. It's everywhere. We're all under a lot of stress. That emotional stress, that psychological stress creates chemicals in our body that can throw the system out of whack every bit as much as mercury or any other toxin. So we have to remember to look for that. All right, so today's talk is on energy. And ultimately, as we know, everything depends on energy. All the good things we think about in life, the ability to enjoy the special moments in life, rely on energy. If we don't have it, we're not going to enjoy much. We're not going to live a good life. We're not going to live a happy life. So energy is critical to every process in our body. And ATP, adenosine triphosphate, is the energy currency of the human body. If we have no ATP, we have no energy. ATP, think of it like an exchange. If you went to Europe, you might exchange your dollars for euros. In the body, there's only one currency in the entire universe of the body, and it's ATP. So what does the body exchange for ATP? Fat, protein, carbohydrates. Every macronutrient we eat, every calorie we consume has to be exchanged for ATP. If we can't make the exchange, the body doesn't get the energy. So it's an important part. It's like having money, it's like traveling to you name the country. It's traveling to France, and all you've got is dollar bills, and nobody takes dollar bills. You can't. So you're saying, well, I've got money. I consume calories. Why don't I have energy? Because it has to be converted into ATP before you can use it in your body. So we'll talk more about that, because that's done in the mitochondria, and I'll show you a picture of what the mitochondria look like. So these little kind of bean-shaped organelles almost, if this is the cell, this is the whole cell, here's the nucleus of the cell, and this is what we call the cytoplasm. Well, out here in the cytoplasm, one of the little organelles that is your basically cellular generators, it produces the energy, is the mitochondria. So this is a big blown up picture. It has an outer membrane and a bunch of inner membranes, and it's in this place that oxygen and food enter into the mitochondria, and through a very complicated series of chemical reactions called the citric acid cycle and the electron transport chain, ATP is produced. So, every cell has a couple, anywhere from 200 to 2,000 mitochondria inside each cell. And remember, we have close to 100 trillion cells, so it's a lot of mitochondria. I'll give you an example. If you look here, if you took the mass of the heart, the weight of the heart, 1/3 of the weight of the heart is mitochondria. Because think, what organ needs more energy than the heart? Only one. That's the brain. Although, some people we meet, we're not so sure. They're missing mitochondria, but for most of us who are thinking, the brain has the most mitochondria in the body. Second is the heart. And you can look here, 80% of all energy in the body is utilized in the brain. Now, mitochondria are the cellular energy generators. They're little factories that produce this energy. Again, they take the calories you consume, combine them with oxygen, and turn them into ATP. That ATP runs every reaction, every muscle twitch, every thought, every blink of the eye, every scratch of an itch, you name it. If you don't have ATP, it's not going to happen. Now, what's the problem? In that process of producing ATP, there's a cellular exhaust. Think of it like an engine. You put in gas, you put in oxygen, you have a little spark, and that ignites it, and out comes exhaust, out the tailpipe. Well, there is exhaust in mitochondria. There's a byproduct of energy production is free radical formation. And remember, free radicals are those unstable oxygen compounds that when you slice that apple open and the apple turns brown, that brown color are free radicals in the air, in the oxygen, attacking the tissue and basically rusting it out. It's rusting that living tissue. So if you take that apple and you squirt the lemon juice on it, the free radicals in the air, which are called oxidants, just like rust is an oxidant, doesn't attack the apple. Why? Because antioxidants in the lemon juice neutralize the free radicals. That's why antioxidants are so critical to keeping our body healthy. Prevents aging, because the oxidative process is the aging process. So that brown on the apple can be remarkably delayed, when you squirt the lemon juice, when you have lots of antioxidants. So the downside of energy production and having a lot of energy is that it creates these free radicals. So we need to have a system to deal with this normal byproduct, sort of a biological exhaust. Now, what do free radicals do? We talked about it a little. They rust things, and they rust vital cell structures, including DNA, the genetic material, other cell organelles, including, and most importantly, the very mitochondria that produce them. So think of what's most susceptible to free radical damage, because the exhaust is happening in the mitochondria. So mitochondria are equipped with some of the most powerful antioxidant enzymes of anywhere in the body. Glutathione, superoxide dismutase, catalase. These are three major enzymes that are present in very high quantities in mitochondria to trap that. It's kind of like the exhaust pipe or the catalytic converter. It prevents that exhaust, those free radicals, from damaging out the mitochondria. So you can see already, if we don't have enough antioxidants, those mitochondria burn themselves out. And when they burn themselves out, that cell, whatever it is, if it's a nerve cell, the battery, just think of a battery in a flashlight. If it goes dim, there's no light. Eventually, the battery dies, there's no light at all. It goes from dim to completely out. That's what happens. The cell just dies. And then that nerve no longer functions. You lose enough nerves in the substantia nigra of the brain, you get Parkinson's. You lose enough nerves in the cerebral cortex, you end up with Alzheimer's. You lose enough nerves in the spine or the spinal column, you can end up with MS. So all these things depend on healthy mitochondria and antioxidants to protect those mitochondria. So you need good batteries, and you need, just like when a battery leaks, and it destroys the whole flashlight. We've all had that happen. That's what happens if mitochondria don't have antioxidants. So oxidative stress is a common cause of cell damage, and it's one of the three common pathways of all illness: inflammation, oxidative stress, and mitochondrial damage. So now the problem with rusty mitochondria: no ATP, right? No energy, no light, abnormal cell function, and cell death. This is an ATP molecule, adenosine with a sugar molecule, and the TP triphosphate stands for 3 phosphorus molecules that attach on. So you get a little energy with the one, some more energy, and a lot of energy. So this is the dollar bill of the body. So how do we protect ourselves? Like I said, we use built-in antioxidant factories like glutathione, SOD, and catalase. If you look at the top of the chain, top of this pyramid here, this is increasing protectiveness. And many people never even heard of these enzymes, right? Because we think antioxidants, we think, oh, take plenty of vitamin A, vitamin C, vitamin E, CoQ10. Those are all down here, but they're among the weakest compared to catalase, SOD, and glutathione. The problem is there's only a few forms of glutathione that get absorbed. So normally what we have to do is take certain herbs that stimulate the body to make more glutathione. Or we take the building blocks, like the right amino acids, to make more glutathione. So remember I talked about that little yellow pill, Protandim? Protandim, the guy who discovered Protandim, Joe McCord, discovered SOD. That's the top of the food chain. That is the most potent antioxidant, or what we call endogenous. It means it's already built into the system. We don't have to take it like we would a vitamin C molecule or anything. It's built in. He discovered this SOD molecule, and that Protandim, that little yellow pill with the 5 herbs it has, almost doubles or triples the production of SOD in your cells. Pardon me? SOD, sorry, it stands for superoxide dismutase. It's an antioxidant enzyme. And just to give you an idea, SOD, if you take a molecule of vitamin C and you take a free radical, one unstable oxygen particle, one molecule of vitamin C essentially will neutralize one molecule of a free radical. For SOD, a molecule of superoxide dismutase will neutralize about 1 million free radicals a second. So it's the difference between, if you think of free radicals as fire, it's the difference between shooting a squirt gun at a house fire and having a sprinkler system in every cell in the body that rains down SOD. Yes, it should. But this is where those little genetic variations come in. One of the genetic variants we test for is the SOD gene. Some people do not regenerate it as well as others. So in those, we have to work around it with giving different nutrients that help to increase the superoxide dismutase. So that's where the herbs, and ironically enough, you look at that protandem, that little yellow pill, the 5 herbs in there go back to ancient Ayurvedic medicine, Chinese medicine. I mean, it amazes me. These things have been used for centuries. We just didn't know the mechanics of how they worked, but people were astute enough to say, hey, take some of this herb, some of this curcumin or turmeric, some of this green tea, and people got better. So that really is what makes up these top of the food chain here. But again, these, remember that the mitochondria can be easily overwhelmed by toxicity or too many free radicals. So you need to have these antioxidants to protect our cells. So a diet in mitochondria, what increases the health of the mitochondria? So we want to know, how do we make healthy mitochondria, and how do we make more mitochondria? Because we want more energy. I mean, I do. I think we all do. Well, healthy fats for one, because these little molecules in the green and yellow here are a phospholipid membrane. It's a phosphorus molecule and a lipid, a fat. But these are healthy fats. For these membranes to stay healthy, and this is the membrane inside that bean-shaped mitochondria where all the, look down here on this side of the membrane, this is where all the energy is formed. See, ADP goes to ATP. There are 4 basic complexes that create the energy. Complex 1, 2, 3, and 4 here, and the electrons move along here till we finally come out with ATP. But these complex chemical reactions occur within this membrane. So we need healthy membranes, and to get healthy membranes, we need healthy fats. And what are healthy fats? Fish oils, omega-3s. Go ahead, Alice. Yeah, this is complex 1, and you can see it uses some vitamin B3 derivatives, NADH, to make NAD+. And then complex 2 takes that, and it adds in this, I don't even remember what this stands for, but it's another, I think it's riboflavin or B2. And then it goes to this third complex for a certain high, I mean, this is what every basic student studies in the Krebs cycle and basic biochemistry. But I'm about 30 years out from that, so I don't remember the details. But it's complicated. And it's all nice and simplified here, but you can see it depends on healthy membranes. So we always want healthy omega-3 fatty acids. They're essential to fluid, flexible mitochondrial membranes so energy can be produced. Now, other things that affect diet, other dietary measures that affect mitochondria. Remember, and this is something that's very interesting, a deficiency in nutrients. If you go back to this picture of the mitochondria, see, certain nutrients are critical to producing this energy. You need NAC, which is N-acetylcysteine, D-ribose, which is that basic sugar. Remember I showed you that looks like the 5, what's that? Pentagon, the pentagon-shaped sugar, the 5-carbon sugar, magnesium, carnitine, B2, B3, lipoic acid, CoQ10, and NADH. If you don't have these nutrients, energy in terms of oxygen and food cannot be converted. It's like taking your money to a currency exchange place and there's nobody at the window. There's nobody. You need the people working at the window to take your dollar bill and exchange it for francs if you're going to France, or take your calories and exchange it for ATP in the human body. So what happens if we're missing some of these nutrients? This is one reason that a lot of people can't lose weight. If you don't have enough of these nutrients to shuttle the calories into the mitochondria, the fat, the protein, and the carbohydrates back up. They back up in the bloodstream. They can't go into these mitochondria. It's like they're waiting to be served, and the line gets longer and longer. And what happens to fats and carbohydrates and proteins that are sitting around in the bloodstream that can't go into the cell? The body converts them into fat. Yeah, or storage, sugars, glycogen, or whatever. But so you see, it's very important that those nutrients, if there's a blockage here, or these mitochondria are gummed up and not working well, Your food goes right into fat. It doesn't even turn into energy. So what happens? Your body then gets hungry and it craves more, and you eat simple sugars. So the body can use sugars pretty quickly. The brain can use sugar very quickly, but these other food items don't get metabolized. So yeah, and I'll show you later on. Yeah, we'll talk about the two tests that we can test for the mitochondria. So the deficiency in nutrients slows down, causing fatty acid, carbs, and proteins to back up and become stored as fat. Now, let's see. Other things that affect the mitochondria, elevated homocysteine levels we already talked about, because glutathione is, remember, glutathione's one of the major antioxidant enzymes in the mitochondria. So if you're deficient in B6, B12, folate, or trimethylglycine, a methyl donator, then your body doesn't have the glutathione it needs to protect the mitochondria, and your mitochondria are no longer healthy. So that's why we measure homocysteine. It's very important. Out of balance hormones. If your cortisol levels are high from stress, that will put a strain on the mitochondria, because same with slow thyroid function, any hormone imbalance. These are the other systems, the tacks under the foot. Inflammation from any source will damage the mitochondria. That's another thing. If you eat too many saturated fats or trans fats or mercury or toxins, they're directly toxic to the mitochondria. So they get inside the cell, they circulate around, they hit a mitochondria, boom, it's like radioactive to them. They just, kill the mitochondria. So toxins are a big thing. So what are the diseases linked to mitochondrial disease? Autism, Alzheimer's, Parkinson's, depression, bipolar, brain aging, obesity, diabetes, heart failure. Really, you could almost put anything on the list. Those are the biggies, the brain and the heart, because that have the most mitochondria. So when energy starts to go bad and mitochondria go bad, the first place we tend to notice it, brain disorders, depression, bipolar, Parkinson's, Alzheimer's, and heart disorders, congestive heart failure, a weak pump, things of that sort. So how does the body say ouch? I borrowed this kind of phrase from Dr. Hyman. He says there's only so many ways the body can say ouch, and he's right. And these are the three common pathways for all illness. Inflammation, remember, not enough fish oils or too many saturated fats are what create inflammation, or chronic emotional stress can create inflammation, toxins create inflammation, but inflammation's the final common pathway. Oxidative stress, meaning free radicals, those unstable oxygen particles. Now remember also radiation. So radiation is just a form of oxidative stress. So when we fly in airplanes cross country, there's a certain amount of radiation that if we have antioxidants on board, it protects us. Okay, same with if you're too close to a radioactive source. Some people are afraid of this electromagnetic pollution, they call it now, being near wires and stuff like that. The data is really not clear, but it's probably going to turn out to be something like toxins. There's some people that are very susceptible and most people aren't. But and then mitochondrial injury. So these are three common pathways for disease. And remember last week in the detox last month, we talked about neuroprotective strategies. We talked about the therapeutic nihilism, that doctors just saying, oh yeah, you have Parkinson's, sorry, we'll just take this and, see us when it gets really bad and we'll up your medicine. That idea that there's nothing we can do is not true, because we can measure these defects in inflammation, stress, mitochondria. These are tacks, and we can sometimes remove them or lessen them. Not always, but most of the time we can do something. So those are called neuroprotective strategies. We actually make clear effort to protect. We have a plan. We need a plan in place to really protect our mitochondria, and that's what neuroprotection is. So remember here we talked about if functional medicine marks the end of therapeutic nihilism. So we don't say if you have mercury toxicity, we don't wait for your decline. We say, look, if you've got mercury toxicity, let's get rid of it, protect your mitochondria with essential nutrients and antioxidant therapies, and take that tack out. Let's get it better. So we've already talked about this in the inflammation module, but just to remind you, it's the other tacks. It's hormone imbalances, digestive disorders. Remember how often abnormal bacteria in the gut can cause inflammation, gluten intolerance, food allergies. All these things cause inflammation in the gut that leaks into the bloodstream and then goes into the cells and destroys the mitochondria. So toxins can do it. Energy malfunctions can do it. Nutritional deficiencies like the B12, B6, and glutathione, stress, weight, solvents, heavy metals, and inadequate omega-3s. What causes oxidative stress? Here's radiation. Here's emotional, psychological stress. Injury or trauma. Aging causes infection, poor diet, pollution, drugs. Okay, all these can lead to oxidative stress, the loss of glutathione, GSH is glutathione, and then cellular aging and disease, but the mechanism is loss of mitochondria. So I'm not going to go into this too much, but I want to mention the name of this because you hear a lot about it. How is the brain damaged? How are mitochondria in the brain damaged? That should read how are I don't know. Which one should it? Do you have any English? How are brain mitochondria damaged? Somebody's going to mark me with a red pencil. Either way. Yeah, because mitochondria can be singular or plural, I think. Well, it's what we call the NMDA receptor, which stands for N-methyl-D-aspartate. The NMDA receptor is, you see that familiar cell membrane, the phosphorus and the lipids, and then a protein here that sits here that's called the NMDA receptor. When NMDA receptors are stimulated, and what stimulates them? Toxins. Aspartame is an excitotoxin in diet sodas, yeah. So, well, again, I don't want to say it's bad. Everything's balanced, but it's definitely an excitotoxin. So for some people who are already in a hyper state, you don't want to give them this stuff because it stimulates this receptor, which opens a gate that allows calcium to flow in, and it's the flow of calcium triggers a bunch of different molecules that produce lots of free radicals, damage the mitochondria, and lead to cell death. So NMDA receptors can be stimulated by mercury, arachidonic acid, which is in saturated fats and red meats, cortisol, homocysteine, high sugar, high insulin levels. All those things stimulate this receptor and trigger the overexcitation of mitochondria and eventually cell death. So you can see there are whole books written by very, God bless these people who spend their life, I mean, Alice, you worked in labs most of your life. You know, people will spend their entire life working on this one receptor or one part of it to figure out how it works. And it's critical because a lot of the Alzheimer's drugs, by the way, work to reduce stimulation of this NMDA receptor. So you reduce stimulation, you reduce overexcitation, you reduce cell death, you reduce the loss of the neuron, the loss of the memory, because the memory is the neurons. So you can see there are certain things that we can modulate the overstimulation with. In particular, magnesium is a great relaxant. It helps with blood pressure, it helps with nerves, and many of us are not sufficiently, we don't have adequate levels of magnesium. So we prescribe magnesium a lot to patients that need it. And we can measure red blood cell magnesium in the blood. Zinc modulates the NMDA receptor, so it takes away the overstimulation. GABA is gamma-aminobutyric acid. It's what Valium works on. Valium is a GABA agonist. Valium relaxes us by producing GABA-like molecules that stimulate the GABA receptors. Taurine, vitamin B6, vitamin D, N-acetylcysteine, catechins in green tea. All of these act as brakes on the overstimulation of the NMDA receptor. So what is aging really? It's the slow destruction, damage, and decay of our mitochondria. I mean, it's pretty much the batteries run out. And depending on where they run out, you end up with the symptoms. They run out in the muscles, you're weak. They run out in the brain, your mind doesn't work as well. They run out in the heart, you get congestive heart failure. This usually results from nutritional deficiencies, low level of antioxidants, exposure to toxins, allergens, infections, and stress, although we all age, right? I mean, but the point is what they call rectangularization. We want to go up to maximum function. We want to stay there as long as possible, and then at the end of our lives we want to go boom, right? That's what they call the rectangularization of the life curve. We don't want this, you know, up and then this slow, because none of us want that. I mean, nobody I know. So the little girl's doing a school report, talks to her daddy. Hey, Daddy, I'm doing a school report on the aging process. Can I interview you? It's painful, right? Yeah, we're all very experienced. See, who says we're not experts? Here's some wise advice on aging. Don't let aging get you down. It's too hard to get back up. Hey, it takes me a long time to find these funny things, you know. So again, very quickly, how do we protect our mitochondria? Certain nutrients, we'll go into this in a little more detail, especially resveratrol from the red grapes, and there's a nutrient called PQQ, paraquinone, which protect our mitochondria, and actually PQQ is showing itself to be something that may actually increase the number of mitochondria, what we call mitochondrial biogenesis. We can actually make new mitochondria. So also things like CoQ10, I didn't put that here, but look at heart failure. We have studies of people who have severe heart failure. The pump just doesn't pump out enough blood. They pump out 35% of the blood volume per beat. That should be 65%. We call that congestive heart failure. On CoQ10 alone, we can reverse a tremendous number of patients that have congestive heart failure, because what happens? Nobody thinks to give CoQ10 to heart failure patients. We just give new drugs that stimulate the heart even more. But the mitochondria depend on CoQ10 to function well. And the heart is made up of a third of the mass of the heart is mitochondria. So you can see once we get those batteries back going, hey, suddenly that toy is running fine. You know, now it's working great. Just like when we put new batteries in my daughter's things, I mean, they didn't work before and now they work great. So if we can, it's like putting batteries in our mitochondria, resveratrol, PQQ. Yeah, PQQ is another supplement you can get through Life Extension now. Yeah, it is out. Antioxidant-rich foods protect them, because remember, those antioxidants get in the mitochondrial membranes and keep that exhaust from destroying it. Boosting our endogenous antioxidant enzyme systems with things like Protandim, N-acetylcysteine, which improves glutathione production. You can take what we call liposomal glutathione in the mouth. You can spray it and it gets absorbed in. Catalase is a little bit harder, but Protandim increases all three. Calorie restriction. Many of you have heard, you know, you can extend your life with calorie restriction. Have you heard that before? No, that's never really been an option for me. I like to eat too much. No, I mean, like, there are really people, because we've done studies for years in animals and rats, and it shows, yeah, if you restrict their calories by about 30% of what they need to function, they live like a long life. Yeah, I'm thinking, okay, I believe in living a good life, not just a long life, but they do live longer. So can you think why? Can you put it together? Why, when you eat fewer calories, would you live longer?
Well, if the calories you're taking in are good ones.
Yeah,
right?
it's
Because
yeah. If they're bad ones, you're not going to live long. But here's the simple reason. You'll get it as soon as I say it. Because the calories, right, have to get exchanged in the mitochondria for ATP. The mitochondria, the more calories you throw into them, the more what they produce? Free radicals, right? Because it's a natural byprocess of oxidation, of ATP formation, is free radical formation. And the more free radicals you have, the faster you rust. So you stop the rusting by not eating as much. it's like you can keep your car from rusting by keeping it in the garage. But if you never get to drive it, what fun is it, you know? No, anorexia will eventually kill you because that's a whole different. This is just calorie restriction. But and then lastly, physical exercise increases the health and the number of our mitochondria. I'm going to briefly talk about the SIRT1 gene. This is a family of genes that was discovered in yeast by Dr. Leonard Guarente at MIT. And actually, the SIRT1 is the human gene. The SIRT2 was the equivalent in yeast. But in humans, this gene is called the SIRT1 gene, aka also known as the skinny gene. And basically, it's the master control switch. It's a piece of our DNA that is a master control switch for healthy aging, and it does it by balancing blood sugar and increasing insulin sensitivity. And so what I'm trying to say here is we're back to sugar. And I know we were talking about Halloween. It's a bad time to talk about sugar. But sugar has a dramatic toxic effect on mitochondria if you eat too much simple sugar. So if we can turn on this SIRT1 gene, and this is how resveratrol works, so we'll get into that in a little, and that's how it works. It protects the mitochondria by keeping the blood sugar at a healthy level. So increasing the activity of the master SIRT1 gene produces proteins that protect cells from inflammation and oxidative stress, and that, of course, improves mitochondrial function, as well as sugar control and insulin sensitivity. So if we look at the aging resveratrol connection, this is Dr. David Sinclair at Harvard, who was a student of Guarente, and he's the one that discovered that resveratrol can extend life in rats by protecting their mitochondria, and it does it by activating the SIRT1 gene. So resveratrol is basically a phytonutrient, and they turn on some genes and turn off other genes. Remember when we talked about nutrigenomics? In the very early session, we talked about how certain foods that we eat can go to the genetic structure, and they turn on certain genes that do good things, and they turn off other genes. So our food is not just calories, but it has information in it. And the information seems to be contained in these phytonutrients or polyphenols. Those chemicals have a way of going right to the DNA and telling it to do something good or do something bad. In this case, it controls blood sugar, lowers appetite, increases anti-inflammatory effect, protects mitochondria. So we're learning a lot about how food interacts with our genes. So that's how resveratrol works. It protects the mitochondria. Problem is, it's in red wine. Everybody knows that. But you need 750 to 1,500 bottles of wine a day, which makes it hard to get around, in order to get enough to turn on the blood sugar control and insulin sensitivity. And it does a whole bunch of other things down here. But basically, it opposes the effects of aging by modifying 144 out of 150 metabolic pathways controlled by genes that control mitochondrial function. And here's PQQ. Life Extension makes a form of this. It acts as an antioxidant like CoQ10. It favorably modulates gene expression and activates genes that promote formation of new mitochondria, as well as normal fat sugar metabolism. And it also protects mitochondrial DNA from oxidative damage. Oh yeah, you can take both. Absolutely, you can take both. And we have patients with heart failure on both, no question about it. Lots of CoQ10, lots of PQQ. Sugar, we talked about how it leads directly to inflammation and oxidative stress, which causes mitochondrial injury. And children of diabetics actually have underperforming mitochondria that are more susceptible to injury. Mitochondrial diabetes and obesity. Obese people have fewer and more poorly functioning mitochondria. Remember, we talked about how if they don't function well, food doesn't get metabolized appropriately, backs up, gets stored as fat. Mitochondria and depression. Some researchers suggest calling depression metabolic syndrome type 2. because changes in the brain from oxidative stress and inflammation lead to mitochondrial injury, which leads to altered mood. When you see Annals of Clinical Psychiatry, metabolic syndrome type 2. So we all have this metabolic thermostat, and we want to turn up our mitochondrial thermostat. We want it to burn energy effectively and efficiently. And if those mitochondria are damaged from free radicals, it all gums up and backs up. So we want to give ourselves what's down here called a metabolic tune-up. Now, what is our metabolic rate? It's actually the rate at which mitochondria, because everybody talks about, hey, how's your metabolism? What is it? Well, it's the rate at which mitochondria can transform food and oxygen into energy. Now, you're probably one of the small groups of people that if somebody asks you, hey, what's your metabolic rate? Well, you go, well, that's how fast your mitochondria can turn calories into energy, or ATP, right? It's determined by two things, the number of mitochondria you have and how efficiently they work. So no different than the money exchangers. If you got a bunch of people need money exchange, you go up to the counter. If there's only one counter, the line backs up. If there's lots of counters, the line's shorter. If there's lots of counters and a worker at each counter, it moves really fast. If there's lots of windows but only one worker, it doesn't move fast. So you need both. You need lots of mitochondria, and they need to function efficiently. There need to be people manning the booth. So this is, in fact, why we measure body fat percent, because a lot of this is determined by the ratio of fat to muscle, because there's so many more mitochondria in muscle than fat, that if we have a higher ratio of muscle to fat, a lower body percent fat, we have much more efficient mitochondrial burning. That's why exercise helps so much. We build muscle. Muscle builds mitochondria. And the functioning of mitochondria and the metabolic rates also determined by all those enzymes we talked about that are and nutrients located in the mitochondria. So remember, there was NAC, N-acetylcysteine, D-ribose, CoQ10, B2, B3. If those are missing, any one of them can gum up the mechanism and it slows it down. It's like coming to the office here and Kathy's out. Okay, things move a lot slower if she's not here to help me in the back. So any one nutrient that's out, it's trouble. Oh, we talked about why calorie restriction works, less free radical formation. Here's the actual curve on mice. You see non-calorie restricted is the green line. They live about 35 months. If you restrict 25% of their calories, they live 40 months. 55, they live about 52 months. 65, they live about 56 months. But they're miserable. I talked to them. They're miserable. So don't worry about it. It's a bad method. I've never understood it. But there are a small number of people. I mean, there's whole societies of calorie restriction. There's books on how to live a calorie-restricted life. It's called CR or something.
And they have energy?
Yeah.
Very little food?
Yeah, they have energy. Yeah, they do. So again, we talked about exercise. More muscle equal more mitochondria equal better metabolism. Again, yo-yo dieting. The problem with yo-yo dieting is when we lose weight, it's about half muscle, half fat. But when you gain it back, you start eating again and you gain it back, it's about 80% fat and 20% muscle. It's just like, it's one of those third law of thermodynamic things, entropy. Things tend to get worse on their own. Like your room tends to get messy naturally, but it won't get clean if you don't do anything to correct it. Same with the weight thing. It tends to gain the wrong way rather than the right way. And because muscle burns 70 times more calories than fat, that net loss of muscle slows down your metabolism. And then this is where testosterone levels come in really important, because if you've got enough testosterone levels, as you lose weight, you lose much more fat than muscle. It keeps the muscle built up so you're not going through that yo-yo issue. Aging also. This is a problem with aging. Every decade after 40, between 40 and 50, we tend to stay weight neutral. Let's say you stay at 170 pounds. You will be, at the end of that decade, between 40 and 50, you may weigh the same as you did at 40, but you'll have 10 pounds more fat and 10 pounds less muscle. As we age, muscle tends to disappear and gets replaced by fat. So that alone creates a really serious problem. Weight remains neutral, but body composition changes dramatically. That's called sarcopenia, sarco standing for muscle, penia like osteopenia, loss of bone, loss of muscle. Here's the guy selling the age knot. He has a little age knot suitcase to this middle-aged woman who's looking for anti-aging advice. And he goes, "I can assure you, ma'am, this is the finest anti-aging formula money can buy, and I should know because I've been selling it for over 150 years. See, that guy's got his act together. So here's how we measure. Madeline, this was your question. How do we measure mitochondrial function? Oxygen consumption. Now, obviously, we don't do this test, but exercise physiologists do this. It's something called VO2 max. They have you exercise, hook you up, and measure how fast does oxygen get into those mitochondria, burn fuel, and create energy. So they're able actually to measure how efficiently your mitochondria are working. The way we do it here is we do organic acid testing. This is a urine test that measures the health of the citric acid cycle inside those mitochondria, where those calories from carbs, fat, and protein go in and have to be converted to energy. We can measure metabolite intermediates along that process, and if any of them are elevated or decreased, we know there's a break in the energy formation inside the mitochondria, and boom, there's trouble. There's a mitochondropathy. There's a pathology with the mitochondria. So in this VO2 max, we're basically measuring the rate at which you consume and burn oxygen. The more oxygen you burn, the more calories you burn, and it's a measure of oxygen consumed during exercise. And again, high-end fitness centers will do it. I've never had it done, but all the major athletes do. This is where they found out, like, Lance Armstrong has, superhuman VO2 powers and can burn oxygen much better than us. Here's the citric acid cycle. This is how we measure it with the urine. What you don't see up here is fats metabolized into acetyl-CoA, carbs, and proteins, and then they all enter this citric acid cycle here, where basically this is the chain of energy that goes around, and then down here the electrons go to form ATP down at this end. It's a very complicated cycle, but we look at these intermediates. We measure citric acid, cis-aconitic acid, isocitric acid, alpha-ketogluaric acid, succinic, malic, and based on the levels of these, if they're low, high, if it's high here and low here, we know there's one of these things could be aggravating it. And this is where metal toxicities come in too. Mercury is directly toxic to this step and this step. So you may see a drop-off. You may have normal levels here, and boom, this level here will be low. So based on looking at these metabolites, we can tell what's going on inside those mitochondria. Now, the 5-step plan for improvement, really quickly, we'll go through this because we've sort of talked about it already. It's pretty simple. Eliminate the causes of mitochondrial damage. So if we know something that's damaging it, we stop it. If you're mercury toxic, get rid of the mercury. If you're totally stressed out, we got to manage that. We got to deal with it. We got to make some life changes. Exercise. Eat foods that increase your metabolism and avoid foods that decrease your metabolism. We'll talk about that. Use appropriate supplements to get a metabolic tune-up, and then retest your mitochondria and make sure they're better. So causes of damage, remember, oxidative stress, excessive sugars. You want to eat nutrient-dense, phytonutrient-rich food, whole foods, and eliminate toxins, stress, hormone imbalances. Another problem, we've talked a lot about statins, but the cholesterol drug statins are toxic to mitochondria. So this is the trade-off. This is why anyone who's on a statin should definitely be on CoQ10 to improve the function of those mitochondria, because where statins affect the Krebs cycle, the citric acid cycle, is at the same step where CoQ10 is formed. So CoQ10 can counteract some of the toxicity of mitochondria, but not all of it. Exercise, again, research shows 30 minutes of aerobics 5 times a week gives the most health benefits. For weight loss, takes about 60 minutes, figures. I know, yeah. There's no winning. This is, that's why you can't just depend on exercise for weight loss. You have to deal with the food intake as well. Eat the right foods, avoid the wrong ones. So this is nutrigenomics. How do foods affect our genetics, which affects our metabolism? Sugars, saturated fats, fried foods, trans fats, all these things destroy mitochondria through increased inflammation and free radical formation. And then Popeye had the idea right. Phytonutrient-dense whole foods, plant-based, are what help mitochondrial function the most. Mitochondrial supplements, there's all kinds of mitochondrial supplements that have all those nutrients already prepackaged for you. So if we find out that they're low, we just usually put you on one of these formulas, unless we specifically want to go after the CoQ10 or some others. But we have some like K-Pax, one of our vitamins, is a very good mitochondrial supplement. And there are many other companies, and we can special order specific ones just for you as well. But if you see here, some of the ingredients are N-acetylcysteine, which helps restore glutathione, acetyl-L-carnitine. This is a really critical one that helps shuttle fatty acids into the mitochondria. So a lot of people will see on their organic acid testing, they have what we call ketone body formation. That means the fatty acids aren't getting into the mitochondria to be burned for fuel. We give them a little acetyl-L-carnitine, and boom, their mitochondria start functioning. That's a transporter that takes the fat from the blood into the mitochondria. Coenzyme Q10, the NADH, which we talked about, D-ribose, magnesium, certain amino acids will help. Here's one of the legendary figures in this whole area that, you know, a guy named Bruce Ames out of Berkeley, a PhD researcher, who is the one that really showed that alpha-lipoic and acetyl-L-carnitine can reduce mitochondrial injury and the effects of aging on the brain, leading to improved memory, learning, speed of motor function. So he's just been a brilliant researcher. You'll find a lot of information from him, but he doesn't have any popular books out. It's all kind of research that everybody will write the popular books around. So here's what's called the Michael Jordan phenomenon, because we talked about a lot of different nutrients in there. And you say, well, maybe I should take extra CoQ10, and maybe I should take extra, glutathione, et cetera, et cetera. The whole question is this. If you put Michael Jordan, one of the greatest basketball players ever, on a court alone against the worst team in the NBA, what's going to happen? He's going to lose, right? Even the best guy in the world can't beat a team of players. It's the same with mitochondrial nutrients. You can't just take any one of them to excess. It's the team. You can't give one compound alone. It'll backfire. You need to take a whole series, a nice rounded approach, and that's why some of those formulas that are pre-made are so good. They've got a lot of variety. They've got most of the mitochondrial nutrients in it, and that's the way to go. Let me give you an example of a case study from Dr. Hyman's book on ultrametabolism. This patient, Diane, in her late 60s, was a diabetic for 10 years, had a whole bunch of problems, rheumatoid arthritis, allergies, hypothyroidism, underactive thyroid, reflux, angina, constant fatigue, and depression. At 5'4", she weighed in at 250 pounds, so pretty heavy, on diabetic meds, antidepressants, cholesterol, blood pressure meds, arthritis, and thyroid meds. She comforted herself with, comfort foods, breads, pasta, muffins, ice cream, was too tired to exercise, and even on the meds, her blood sugar and insulin levels were high, triglycerides high, had a fatty liver, and her HSCRP, the CRP which we measure in every one of you guys for inflammation, should be less than 1. Hers was 10. Now, what Hyman did was, since diabetics have a problem burning calories they eat, he did an organic acid test which showed she had a problem processing fats and carbs. Now, rapidly absorbed carbs like white bread caused her blood sugar to rise at rates that exceeded the ability of the mitochondria to burn it, so it backed up and got stored as fat. So those mitochondria are getting biochemically jammed up and weren't burning fuel efficiently. So even though these things sound simple, if you do them consistently, here's what he did. He addressed the damaged mitochondria by reducing the sugars in her diet. Again, not always easy to do. Moderate exercise got her on high doses of alpha-lipoic acid, CoQ10, carnitine, and her metabolic engine improved. He put her on a whole food, sort of more natural diet. And then 1 year later, she had lost 45 pounds. Her inflammation was gone. Her fatty liver was gone. Sugar and triglycerides were back to normal, and she started to have more energy, etc. Now, that took a year, and she's not perfect yet, but it's a year in the right direction. And most of it, if you look at, other than the food, you know, eating whole foods, healthy foods, with a good glycemic index, not too high in simple sugars, proteins to balance them out. But the main nutrients were the alpha-lipoic acid, CoQ10, and carnitine. And just by improving her metabolic engine and the mitochondria, and then, of course, the exercise increased the number of her mitochondria. So remember the therapeutic nihilism we talked about with Dr. Cummings in regards to Parkinson's, this idea of neuroprotection. We must focus on prevention and detoxification as careful and deliberate strategies. Symptom management must give way to identification of environmental hazards that can be eliminated and chemopreventive strategies. What he means is the right nutrients, the right supplements to help improve our mitochondrial function and antioxidant function. So we see we've got, again, it's genetic problems with our environmental toxicities and the individual choices we make. And here's a little muscle man mitochondria making a show to tell you, you take care of me and I'll protect you. And again, just to remind you about the Protandim, this little yellow pill by Dr. Joe McCord, which is a NRF2 activator that goes into the nucleus of your cell and hits a whole series of genes that improve sugar metabolism, reduce inflammation, reduce oxidative stress, etc. And McCord's studies show that a 1 pill a day on his supplement decreased the oxidative stress from that of a 70-year-old to a 20-year-old within a month, and it maintains you at that level. So it's a very critical factor to help our bodies. And then finally, the lighter side, energy and mitochondria, the lawyer's petitioning for his client to the judge. Your Honor, my client is an eminent scientist, and he pleads not guilty on the grounds that his mitochondria made him do it. Now, that was hard to find. Yeah, couldn't help himself. So that's it. Questions, concerns? The Protandim, we have some here in the office, and then you can order right off the website. It's actually the same price. You just go on the website and can order it off the mdPersonal.com website. But I think we still have some bottles. Every now and then I have some here. We get it right here. Interesting, huh? Never really thought about mitochondria like that, but But we're testing, the test we drew and you will check the organic acid. So we'll know how your mitochondria are doing in a little bit.
That takes a long time.
Yeah, 3 weeks to get that back. So once we know, we'll let you know. All right. Well, anyway, officially, thank you, everybody. Thanks for your attention, and may your mitochondria live long and prosper.
And the thyroid and the testosterone. It's important that you're doing that.
It is. It's a very important thing.